Yes, it is visible, sir.
Okay.
Yeah.
As per the request from the organizing committee, I have tried to keep it very simple. Basically, I will start from the fundamentals of image processing using MATLAB. So before starting the programming in MATLAB, I thought that I should introduce some of the terms in image processing from the very basics. So first of all, what is digital image? Basically, digital image is nothing but a 2D matrix. Okay, so if we can visualize it like a 2D matrix, so each and every cell of that matrix will contain some value. That is the intensity for that particular pixel. So what is pixel? So pixel is basically the smallest unit of digital image. So each of the pixels have some intensity values. We will see later on. Now, what is processing? So processing is the computing over the digital image. So based on the computational complexity, there are three levels of processing. The first level is low level, that is input and output, both are images. For example, we can pick the noise reduction, contrast enhancement, and for mid-level processing, it is the outputs are the attributes extracted from the input image. So basically inputs are image and output are some attributes. So for example, we can pick segmentation, classification, and for the higher level processing, it's the recognition of individual objects using image. Now see, there are different applications. I mean, vast area of application of image processing. Okay, so I have mentioned here few of the application areas that are image sharpening, restoration, medical imaging. I mean the applications over the medical field, remote sensing, transmission encoding in machine learning domain, in computer vision, color processing, pattern recognition, and object recognition. Now, how the image pixels are sensed? There are variety of sensors. So basically, we have three type of sensor: the single imaging sensor, line sensor, and array sensor. So single imaging sensor senses one pixel at a time, and line sensor senses one dimensional array of pixels at a time, and array sensor, it senses two-dimensional matrix or two-dimensional array at a time. Now, how to sense image from, from a view with the help of with the help of single sensor. So you can place that sensor over a line where the sensor will move in one direction only, and you just plug your film or the image in some rotator which will rotate. So in that way, it will scan throughout the image to get all the pixels from that image. Now, how to use the line sensor? Basically, here in that picture, you can see the line sensor will be placed in a direction, and in another direction, line sensor will be moved to scan the complete image. And how we can use that line sensor to sense, 3D object. So if we circularly bend that line sensor like this, okay, we can sense a 3D object and get the cross-sectional view like in MRI and PET imaging. Now see, in real life, how the image acquisition goes on. At first, see here, with the help of some illumination source, the object is illuminated, and from the object surface, some amount of the light is getting reflected or sometime passed. Why not always reflected? Because there are some imaging area where the light is not reflected, light is passed through the object, such as for X-ray imaging, the light passes through our body and the amount of light which has been passed, it has been sensed. So there are two options. One is reflection, another is transmission over the object. So whatever it is, uh, it has been passed through a imaging system. So imaging system contains imaging sensor as well as one mapping device which maps the image in a 2D uh, coordinate. So from there, you can see this image is not digitalized. Okay, so we need to digitalize and discretize that sensed energy. So this is the digitalized version of the sensed energy. You can say it as digital image. Now we can see here in that equation there are two components which are responsible for generating one pixel intensity, that is illumination component and reflectance, or we can sometimes say transmissivity. So both these components are responsible for the image intensity. So you can see the illumination can be 0 to infinity, but in case of reflectance or transmissivity, we can get from 0 to 1. That means 1 means 100% reflectance or 100% transmission, and 0 means no reflectance, no transmission. So based on that two component, our intensity value will be decided. So it is from 0 to infinity. Now we will see how to represent digital image. Here we will see that there are two dimensions. One is x, and there is y. So in normal mathematics, we know that this is the x direction and this is the y direction. We used to give that example everywhere in mathematics. But in case of image, we will see this is the x direction and this is the y direction. Based on that coordinate value, coordinate points will be decided. So here in that particular image, this is the black part, this is the mid gray part, and this is the complete white part. So if I assume that complete black will have intensity 0 and mid gray intensity 0.5 and white intensity 1. So you can imagine that this the pixel which are residing in that blackish part will be at the ground level. This is the x direction, this is again y direction, and this third direction, it is showing the intensity of that particular pixel, or sometimes we can say amplitude also. So the black region pixels are grounded, then the mid gray have some value, and for the white you can see the maximum value. Okay. Now, how to represent digital image in matrix format? So you can see it's a 2D matrix starting from the coordinate f0, 0 to, in this side in y direction it is up to n minus 1, from 0 to n minus 1. That means we have n number of columns, and in x direction you see we have 0 to m minus 1. That means we have m number of rows. Okay, but in case of MATLAB, when we will represent image in MATLAB, we will see the coordinate starts from 1 1. Okay, in MATLAB the array starts from 1 1 position. So in reality f00 is f11 in MATLAB. So you can see in that way it will be from 1 to m in x direction and 1 to n in y direction. Okay. Now it will be simpler mathematics for calculating the image size and how many number of intensity levels will be there. So it completely depends on how many bits you are taking to store a particular pixel. If you take k bits to store a pixel, then we will have 2 to the power k number of intensity levels. Okay, so L is saying the number of intensity levels. So L equals to 2 to the power k. Suppose we are taking 3 bits to store a particular pixel, that means we will have 2 to the power 3, means 8 pixel intensities. These are 0, 1, 2, 3 to 7. Okay, so intensity starts from 0 and goes up to L minus 1, the maximum intensity level minus 1. So 0 means complete black, and the maximum, the highest most intensity level is pure white, and in between everything is gray. I'm talking about single channel image. Okay, I'm not talking about the color image, the grayscale image. So single channel grayscale image, you will get 0 to L minus 1 number of intensity. If we have 8 bits for storing intensities, then we have 2 to the power 8 number of intensity levels. That means 256 intensity level. So we will have intensity from 0 to 255. 0 means complete black, 255 means complete white. So in that way, you can easily calculate the size of a digital image. So if you have m number of rows and n number of columns, that means m is your height and n is your width, and you are taking k bits for storing. So total size of the image will be m into n into k. Okay. Suppose you have 400 by 600 image and you are taking 8-bit image. That means you are taking 8-bit for storing a particular pixel. So total size will be 400 into 600 into 8 bit. You can convert it into kilobyte, megabyte. Now we need to know very basic thing of image processing, that is the neighborhood of pixel. So for one pixel, we have 4 neighbors. Who are the 4 neighbors of one pixel? This is suppose x, and this is y, starts from 0, 0. So if this point is xy, the pixel is xy coordinate. Now it will have 4 neighbors. So this is say one neighbor, this is another neighbor, this is another, and so here this is the east one. So it will have the coordinate what? X, comma y plus 1. The south part will have the coordinate x plus 1, comma y. Now this one, the north one will be x minus 1, comma y, and the west one will be x, comma y minus 1. Okay. In that way, we have 4 diagonal neighbors also. So these are this one, this one, sorry, this one, and this one. So let me take another color to identify those pixels. This one, this one, this one. These 4 are the diagonal neighbors. In that way, you can easily get the coordinates of those 4 diagonal neighbors. So we have 4 neighbors, then 4 diagonal neighbors. All total, we have total 8 neighbors. This is making 8 neighbors of the pixel. Okay. So you just combine the first 4 neighbors and then diagonal neighbors. Total 8 neighbors. Now, based on that neighborhood, we have adjacency. Adjacency between 2 pixels. So if 2 pixels are 4 adjacent, that means if it is P, it is Q. So if Q is residing in the 4 neighbors of P, then we will say it is 4 adjacency. And if Q resides in the 8 neighbor of P, it is the 8 adjacency. Now what is M adjacency? M adjacency has been introduced to actually remove some ambiguity. So, suppose I have one pixel P here, another pixel Q here, and in between one pixel. Okay. Now, and most importantly, we need to know the pixel intensities. We are assuming that the intensities are same. Okay. So now, if we have one neighborhood pixel of P here, another neighborhood pixel of P is Q. So we will definitely go in that way, not in that way. If there is no neighbor here in that point in 4 neighbor, then we will go with the 8 neighbors. This is called M adjacency. Okay. Now path. So path is basically generated with the adjacency. We are starting from one pixel, that is say x0 y0 coordinated, and we are ending at a coordinate xn yn. So in between all the adjacent pixels will be the part of path, and if x0 y0 and xn yn are same, then we will say it is a closed path, and path will be changed based on the adjacency what we are taking. Now connectivity. If inside one image some set of pixels are connected with some adjacency, then we will say this is the connected set, and also this is a region. All the component of a connected set will be called together as region. Now the boundary. So if in your image you have one object, say like this, so what is boundary? Boundary pixel is such a pixel which has at least one or more neighbors that are not in R. Suppose this is a set of region, that is R, sorry, R, and this pixel has this neighbor not belonging to R. That means this pixel is belongs to the boundary pixel, and one object has two boundary. One is inner boundary, another is outer. In this example, I have shown outer boundary. Here you can get one inner boundary also. So for being boundary pixel, at least one or more neighbors should be outside that region. And what is foreground and what is background in case of image? So basically, foreground is the union of all the regions in your image. So if you have multiple regions, suppose we have another region here, this is one region, another region here. So union of all those regions are foreground, and apart from these regions, the pixels which are there in your image is belonging to the background. Okay. Now I will come into the image processing toolbox in MATLAB, and I will show the hands-on examples also. So what is the facility of using image processing toolbox in MATLAB? You will get different types of imaging functions here, like for the purpose of image segmentation, image enhancement, noise reduction, geometric transformation, image registration, deep learning based image processing. Okay, and sometimes you will also get help from this toolbox for GPU based processing. We all know for working with the image data or video data, we must use the GPU to get the result in shorter time. We can get result in our system, but it will be, suppose the 2 days result in GPU you will get in 2 hours probably. Okay. Now I will show the import, export, and type conversion of images. So the imread function used to import the image in your MATLAB. I have imported one image. An imwrite function is used to write or save one image in your hard disk. First I will show in PPT, then I will show the codes also. So here I am importing one RGB image. Then I have splitted the 3 separate channels, red, green, blue, of RGB image using that simple tricks. And I have displayed it using the subplot. I hope all of you know the subplot functions in MATLAB. Okay. So 3 separate channels has been displayed, red, green, and blue here. So these are different type conversion functions. So we have RGB image, indexed image, grayscale image, lab image. There are different types of images. So I will demonstrate one which is very common, and mostly we do this conversion, that is from RGB to grayscale conversion. For our less processing or simpler processing, in case of image processing based applications, we convert RGB images to grayscale image. Okay, so the function is RGB to gray. First you read one image, RGB image, and you provide that image in your function RGB to gray. and you will see the result in the grayscale. So I have displayed two images in using the IMSoPair function. Okay. So the first image is RGB image, then gray. Okay. Now let me display it in MATLAB. So I have already detailed code due to the less amount of time here in presentation. So see the first section, I will run section by section. So here in the first section, I will read one image. Okay, let me first comment it out. Okay, let's read that image. It's reading. Okay, now see, I have read one image which is already in MATLAB. I have not supplied it from outside. It is already in the MATLAB image processing toolbox, that is cameraman.tif. So now see, it is a 256 cross 256 image in workspace. You see, it is 256 cross 256 image, and the values of the intensity is UINT, means unsigned integer of 8 bit. That means you will have the intensity range 0 to 255. See the pixel intensities. See, the first pixel has the intensity top left pixel has the intensity 156. Then you can see different intensities. It will not be more than 255 and not less than 0. 0 means, and again repeating, 0 means black, and 255 means white, and in between all the intensities are different shades of gray. So total, if we are using 8 bit for storing one image, we will have 256 gray shades, including the pure black and pure white. Okay. Now, how to write an image? Suppose you have processed one image and you have changed some part of the image. Now you want to save that image. So we have to use the IMWrite function. Now let's, I am saving the image with the name of mycameraman.jpg. Okay, you can change the type of the image also. I am reading that image and I am saving the same image. I'm not doing processing here. I'm saving the same image with the name of mycameraman.jpg. That's why we are using IMWrite function. There we are providing the image variable in MATLAB and a name for that image. Okay, now let me execute that section again. Now see, in my folder, mycameraman.jpg, one image has been generated. You see, in current folder section, one image has been generated, that is mycameraman.jpg. Okay. If we want to display that image, I am so, let's see how it looks like. No changes will be there. This is same image. Now I will show the splitting of channels. See, here we are again using IMRead function to read that image, and now we are splitting into 3 separate channels, that is red, green, and blue. So we need to remember that this is one, 256 cos 256 cos 3 image. That last cross 3 means this is a 3 channel image, the RGB image. I have not read it out. Okay, let me clear the window. Now I will split that RGB image into 3 separate channels and will display using the subplot function. Let me run that. See, this is the input image and IRGB. Okay, this image is 384 cross 512. That means 384 rows, 512 number of columns, and last 3 cross 3 means last 3 is saying that this is a 3 channel image. Okay, so basically this is on RGB image, so we have to split it in three channels. The first channel belongs to red channel. That's why we have taken the first channel here and assigned to IR variable. Second channel here and assigned to IG, and in that way third channel to IB, and displayed it to corresponding file. Okay. Now I will move on to the type conversion. I will read the JPG image, sorry, PNG image, which is RGB image, and I will convert it using RGB to gray function. I will display using PL. Let's run the section. See, this is my RGB image and this is my eye gray image. Here you can see previously it was 384 cross 512 cross 3, but as it is a single channel grayscale image, it is 384 cross 512. Okay, so this is one grayscale image. Now let me again come back to the PPT. Image arithmetic. So I will demonstrate now simple image arithmetic. First, addition. Addition of two images. Here I have taken or read the first image, that is the rice.png, second image cameraman.t. Now if we add the two images, how the processing will be done? So let's assume on 3 cross 3 the intensity are 357 1 2 3 5 7 0, and another image 1 2 3 4 5 3 1 2 0. Okay, now if we add their two image using IMAdd function, we will be adding each and every pixel with same coordinate. 3 will be added with 1 to get the result for the first coordinate. 5 will be added with 2, 5 plus 2. 7 will be added with 3, 7 plus 3. In that way, all the pixels with same coordinate will be added to get the result. Okay. Now, I think one question should raise in your mind, that is, in case of grayscale image, say I have one pixel having intensity 240, another pixel having say intensity, sorry, one image having first pixel intensity 240, another image having first pixel intensity 20. Now if we add these two pixels, we will have intensity 240 plus 20, 260. But in case of grayscale image, we have maximum of 255 intensity. Now what to do with 260? If we are using unsigned integer of 8 bit, then those values which are greater than 255 will be replaced with 255. So 260 will be replaced with 255. So here, when we are adding two images using unsigned int of 8 bit, we will have this kind of washed out loop, because those pixels having intensity greater than 255 will be assigned 250. That means you will get complete white loop. Okay. And to get the actual view, you have to increase your number of bits for storing, so that you can have all the intensities in your range. So if you are using unsigned int of 16 bit, then you will have more intensities, and you can scale it to display properly. Okay, this is the last one. This is actually displaying by scaling, and it is using 16 bit for storing a pixel. Now we are adding a constant value to a particular image. So I have that input image. Now we are adding 50 to all the pixels. See, the brightness will be increased. So we have to remember that to increase the brightness of image, we have to add some constant with each of the pixels. But same thing will happen here also. If you are exceeding 255, it will be replaced with 255. Otherwise, you take more bits for storing. Now subtraction. So here again we are taking same inputs and we are subtracting. So this is the subtracted image. In case of subtraction, opposite thing will happen. It may go negative, below 0. Suppose we have intensity 240 and we are subtracting 255 from there. We will have minus 15. So minus 15 will be replaced with 0. That's why we will get more blackish look, more black pixels here. Okay. Again, we can apply same tricks for storing. We can take more bits for storing and scale it accordingly from 0 to the maximum intensity in that particular range. Now, we can subtract a constant value like addition here. So if you subtract a constant value from each and every pixel, you will guess what? You will get a darker look. Okay. Am I still audible?
Yes.
Yes, sir, you're audible.
Okay. So far, any question?
No, sir. As such, I'm feeling that my general observation is that, sir, you're going a little faster. I mean, for beginners like us, I mean, whenever you're just saying something, we need to absorb. I mean, if there is a few more seconds given to us to absorb before going on to the new slide, then I think that would be better.
Okay, madam. Okay, no problem. You should stop me when you feel that I'm going fast. Please stop me. I will not mind. Okay. Thank you for the suggestion, madam.
Sir, I have a suggestion. Am I audible?
Yes, madam.
Yes, I think the speed is okay, but who has problem, you can share the slides. He or she can go through the slides later on.
Okay. Should I share it in the discussion board or I will share with the organizing committee? They will mail the.
Yes,
Susovan
I
sir,
think that
yes,
will be
you
better.
can
It
share,
should not
yes.
be in the discussion board. It should be with
Yes.
the participants in the closed group who are attending this FDP.
Yes,
Okay.
Susovan sir.
Yes.
Yes, you can share with me. Then we will share it with all
Definitely,
the
I
registered
will share
parties.
with you.
Yes.
Thank you.
Thank you.
Susovan sir, I have some question.
Okay.
You import some image like that pass to where you are adding the two images. So is it always that when you are reading one image, the dimension of both the two images will be the same?
Yes, when you are adding or subtracting or doing any kind of arithmetic operation, the dimension of both the image must be same.
Okay. And another thing is that can you go back to the slide where you are adding two images?
Yes.
Yes, here, right. So I think the last image is the addition of the first two images, right?
Yes.
But why
This
the
is
last
also this image is also the addition of that first two image, but this is 8-bit image and this is 16-bit image. Because of the limitation of intensities, when we are adding, we are getting pixel intensity values more than 255, but we do not have the scope to display more than 255 in case of 8-bit image. So MATLAB has added one logic that if it is going, beyond 255, it will be replaced with 255. Okay, but if you have 16-bit, that means you can accommodate all the intensity ranges. So maximum we will get what? 255 plus 255, that is 510. Okay, so if we are using 16-bit, so we can easily accommodate 510.
means that if that number of bits is varies, then that addition of the two images, the resultant image will be different.
No, it will not be different. It will be scaled accordingly. Okay.
Okay. So because of this scaling
this
problem,
510 will be assigned to 2 to the power 16 minus 1. So in that way, it will be scaled. So the loop will not be hampered.
actually I'm not getting where that last two images means. I think this is only because of this bit problem. Because you say that this image is 8 bit, another is 16 bit, and that's why that these two pictures are different.
Sorry, I'm not getting you.
Means that one picture is 8 bit and another is 16 bit, and that is the reason they are so different.
Yes, that is the only reason.
So that's why I'm saying that if the number of bits are increased, then the resultant the sum of the two images will be different.
No, I mean, in that point scaling comes. So in case of 0 to 255, if we are using 60, I mean total 16 bits, then we will have 0 to 2 to the power 16 minus 1. So there 255 means 2 to the power 16 minus 1. So the intermediate intensities in 0 to 255 will be scaled accordingly. I mean mapped accordingly.
Okay. Okay. Thank you.
Any more question? Okay. Now the image complement. So we know that complement means just like the reverse thing. Okay. So here I have taken one black and white image that is called binary image. So if in our image we have only intensities of 0 and 1, that means this is one binary image. So 0 means black and 1 means white, no other gray shades. So if we complement using that IM complement function, we will get just the reverse image. Zeros will be converted to 1. See, the black pixels are converted to white and white pixels are converted to black. Now the question should be, if we do the IM complement in case of grayscale, so it will be just, I mean, reverse of complexity, I mean, sorry, intensity. If you have one pixel of intensity, say 240, so the complemented intensity will be 255 minus 240 in that way. Okay. Now there are more arithmetic functions. Okay. So let me display.
Sir, I have a question.
Yes.
Sir, what is the command used for converting the grayscale image or RGB image to binary image?
RGB image to binary image. Okay. So for converting RGB image to binary image, you cannot directly convert it. First you convert it in grayscale image. Then you can do the thresholding. Based on the thresholding, you can convert it into the binary image. There is one function IM to BW probably. Okay.
Okay. Okay.
Just
So you are not audible.
I'm not speaking. I'm just doing. Is my screen is shared?
No, sir.
So I think screen share. Is it visible now?
Yes, yes, yes.
Yes, now it is visible.
Okay. See the binary image. Okay. Let me display it. I am so B. This is the binary image of that I gray. From RGB to convert, first you convert it into gray, and from gray to convert it into B. I mean the binary image. So in binary image, if you see, the pixel intensities will be 0, and in case of white part, the intensities will be 1. Let's see where you can get white. There are white, but as this is a large image, this is little bit difficult to find by just traversing here. Okay. So here from here you can actually see the data. using the data collection. Okay, see, this is the coordinate 217 cross 217,94. So if we go 270, oh, see, 5 pixels here. And if you go 217, 92 in column wise. Okay, I may be wrong, it was 90, I guess. So white pixels are there. Okay. Now let me demonstrate that arithmetic operations. This is the addition part. All the codes have been executed. So the first part, if you see, this is the first one, the 8-bit image, addition of two 8-bit image and resultant image is also 8-bit. Okay. Now, if we comment it out, let's also comment this one. See the output, the 16-bit one. Okay. Now we are uncommenting that part, adding the constant values. Okay. So all the codes which are in PPT, I have executed it first, then I have given it in the PPT. So if you get the PPT, you run the same code, okay, you get the result. In that same way, we have the subtraction codes, IM subtract function, okay. And first I have provided two parameters by default, 8-bit subtraction. Now I am subtracting a constant value. And here you can you can see one function, that is montage. And using that montage function, you can display multiple images in single window. I have displayed two images here, you can see, or here I have displayed 3 images. So size should be mentioned, 1 row, 3 columns. That means we will have single row and 3 columns mean 3 separate images. If we have 2 row, 3 columns, that means total 6 images. Okay. So you can use that function. This is very useful function, montage, and you just mention the size, and accordingly you have to provide the images in sequence, in which coordinate or which cell you are going to display the particular image. And it works almost similar like subplot. In case of subplot, we have little bit gap between two images, but in case of montage, we do not have any gap between images. We do not have any gap between two images. Both images are displayed side by side. But if you use subplot to display multiple images in one window, you will get a little bit gap. And this is the complement one. Using IM complement function, I am complementing one binary image. You can see it and try it out using one grayscale image. Now let's see the logical operations. So here I have taken or say generated two images. See, possible to hide it out. Okay. So I have this image A and this image B. Here you can see this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 cross 1, 2, 3, 10 cross 10 image. Okay. So you can see the pixels in intensity is 1, that these are white. See, this is the white part, and here you can see the white part in B image. This is the white part in B image. The same looks accordingly. So these are two input images. I will demonstrate the logical operations with that two sample. So if we do logical OR between, this is like digital truth table. 1 or 1, it will 1, 1 or 0, the output is 0. Sorry, output is 1, 0 or 1, output is 1, 0 or 0, output is 0. So it functions just like OR gate. In that way, if we OR this one and this one, we will get the complete white region here, just like union, it will work. So you can OR here also. One, I mean, for all those pixels, you can see up to, let's say this one, we will get 0 because of 0 and 0. Now this is 0 and this is 1. We will get 1. So this is the pixel. Sorry, here you can see this pixel is the intensity of 1. It will function just like OR gate. And see, which I am just talking about the subplot. If you display multiple images using subplot, you will have little bit gap between images. And the function is OR. You just use OR, and in between you provide your input images, and you will get output. And I have directly displayed the output in IMSO. I have not assigned to in some another image variable. Okay, I have directly displayed this one here in IMSO. You can do it. Now logical AND. So same input images are here, but we know the funda of AND gate. If both inputs are 1, then only output will be 1. That's why only the common region, which is white in between these two images, this common region will be displayed in the output, and all other will get 0. The function is AND function. Now logical NOT. Logical NOT. It is almost similar like the IM complement if you are going with binary image, because all the logical operations which you are demonstrating here with the binary image. So if we do the NOT A, so NOT A will give you the result just the complement of A. Now if we use NOT B, that is zeros converted to 1, ones are 0. See the result. Okay. Now if we do the logical operation between the grayscale image, that means if you do OR, the maximum value will be taken. If you do AND, the minimum value will be taken. And if you do NOT, the reverse value, I mean the subtracted value from 255 will be taken. I think I should stop here because I have only 5 minutes for question answer. If the audiences have some questions,
But sir, you just need to share your PowerPoint today. I mean, it's a request from our
I
end.
will definitely share. Should I share today or just after the end of my session?
No, not for that, because we have this FBP examination tomorrow at 9:30 p.m.
Okay.
So before
Regarding
that, we need to have
examination-
some material to go through.
So
Okay,
regarding
okay.
examination, sir, I have a request to the organizer if it could be arranged on, because Monday is a holiday and tomorrow night would be a little difficult for us to sit and give the exam. If it could be arranged on, I mean, Tuesday in the office hours or in college hours, then it could be, I mean, very feasible to all of us. It is a humble request to the organizers. I don't know they will accept or not. Hello, am I audible?
Probably Sumanto sir may answer this.
Probably Shumanto sir may answer.
So if there is no question, I can summarize what we have and discussed today. Sumanto sir, may I do?
Yes, Shravan sir.
So,
Participants, if you have any question,
sorry.
participants, I think no other question from the participants.
Yes, I will quickly summarize within 2 minutes.
Yes, yes,
Okay.
yes.
So at first we have learned the basics of image processing application areas, imaging sensors, then the digital image representation. Then we have learned the how to calculate the image size, then neighbors, adjacency, path, connectivity and region, boundaries. Then I have entered into the image processing toolbox, how to import, export, and convert in between image types, different functions, arithmetic functions, IM add, IM subtract, complement. Now the logical operations. So in between two binary images, I have demonstrated functions are OR, and NOT. So actually, I have planned to show the geometric transformation today, translation, rotation, scaling. I will display these things tomorrow, and then I will display convolution and filtering over images, different types of filters, then different contrast enhancement techniques. This is the end of the first PPT, and I have planned with another PPT which contains the applications. Applications of image processing. This contains the segmentation, the classification using deep learning, I mean the convolutional neural network, as well as I have some texture analysis, the shape analysis. I don't know how much I can cover, but I'll be going with sequence. I mean how I have arranged it. Okay. Thank you. Thank you, Sumanta sir. Thank you all. Sumanta sir, it is over to you.
Yes, Susovan sir. So with your permission, sir, I am stopping the recording here.
Okay, okay.